Welcome all to Attica's first live webinar. So today we've got Casey Delaney from Conqueror Insulated Panels. So we'll bounce through the agenda and then Casey can do his introduction and get started. So agenda for today. So first of all, Casey's going to give a bit of background on himself and Conqueror, and then he's going to explain what PIR is, the panel types, the benefits, installation and detailing. And then we're going to go through a few case studies of where our clients have really proved the benefits of PIR, and then some commonly asked questions, and then we'll open the floor for questions at the end. So take it away, Casey. Give us your background.
Thank you, Amonte. Firstly, I'd just like to thank Attika for inviting myself and Conqueror to this webinar. I've been with Conqueror coming up 5 years. And today we just want to explain a little bit about why would you use a Conqueror panel. A little bit about Conqueror. We started in the factory was commissioned back in 2012 by a previous owner. Conqueror is actually part of the Kingspan Group, which we were acquired by in February 2024. So what they've done is come in and made significant investment into the factory and changed how the product is actually manufactured now. So Conqueror is a separate brand to Kingspan, and we're ideally suited to light commercial type buildings, insulated sheds, and we honestly believe it works very well in conjunction with Attika, the way they build their buildings. The panels our factory is based in Christchurch. We're a true PIR core, and we make the following panels. So we make trapezoidal 5-rib roof wall panels, so it can be used on roofing or walls. We make cool room panels, and we make architectural wall panels as well. So that's a little bit about what Conqueror is and what we do. Moving on to what is PIR. So PIR, it's a bit of a tongue twister, but it stands for polyisocyanurate is the true name for PIR, which is it's a closed cell rigid foam. It's made up by two main chemicals, being isocyanurate and polyol, with the appropriate catalysts and a blowing agent. What it does, it's a thermoset plastic which forms a char in fire conditions rather than melting expanded, like expanded polystyrene does. So what that does, it improves the thermal performance by giving you a lot higher R value than other products on the market. Gives you very good fire resistance, improved moisture resistance. So it's hydrophobic, so it means it's not going to absorb any moisture like other products on the market can. And it gives you excellent dimensional stability, compressive, tensile and shear strength. So we believe it is a very good product on the market. So that's pretty much what PIR is.
Brilliant. We do find when talking with customers, Casey, that people can get PIR confused with EPS, or what people would know as polystyrene. You got a couple of points on the key differences, because they are very different products, and that can be a common misconception.
So obviously PIR is a closed cell foam, so it's not going to absorb any moisture or anything like that. Where polystyrene, being lots of little beads and balls and that go together, it can absorb the moisture content. The other thing is, yes, they do have other retardants and that can go into their product, but generally with the polystyrene, it will. It's not going to perform the same as what a PIR panel will do in a fire situation. So
That's probably the key important part as well. As I know, clients and insurance companies basically say that the old traditional EPS is practically uninsurable. So that's really important to understand, I think, for
yes,
customers.
the other thing with it is you can. It's not quite half the R value, but say you're using a 100 mil polystyrene panel, you could just about get away with a 50 or a 75 mil PIR to get the same R value. So it gives you a higher R value in that
Right.
sense.
Okay.
Which obviously, when you're building a building like you guys do at Attika, is square meterage is what sells a building. So if you're using a thinner panel, that gives you a bigger square meterage on the
Yeah.
overall.
Awesome.
So if we move into our trapezoidal roof wall, so our our roofing is a traditional 5 rib profile. So you can see on the picture there that includes the overlap on the right hand side of the diagram down the bottom. Our panels are 1 meter in width, and we have that's 1 meter coverage, and we have 5 different thicknesses available to suit the different zones around the country. So obviously, you go to the top of the north, you're not going to need a thick as thickest panel as you would if you're going down Central Otago, Southland, where you'd traditionally be using a 150 mil panel. We can Our panel lengths start at 2.4 meters, so that's the minimum that we can run in our factory. But we could go up to a very long 24-meter panel, which the good thing with that, it can reduce the chance of any joins in your roof line, which obviously means less chance of a leaky building or something like that. So we use New Zealand colour steel, and I'm not sure if everyone's aware, but colour steel changed sort of the middle of last year to Maxam steel from the old Endura or Max steel. So all our roofing now comes with Maxam steel. We have 6 main standard colours. Anything outside of that, there can be a little bit longer lead time for the product, but still generally it's not too bad. The internal profile or liner skin, we have standard. We prefer the swaged effect opposed to the flat, but we do run a flat panel as well. As you can see, the minimum roof pitch for our roofing is 3 degrees. If we move into cool room panel, like it says there, it's designed for a wide range of building applications. Predominantly, it is designed for cool room, freezers, and buildings like that, but it is used on a number as a cladding or even down to people building trailers and things like that. So people do use it for a wide range of applications. Is manufactured in the same factory. So we in our factory we have different roll formers. So obviously one for the trapezoidal roofing, one for cool room as well, and then one later on you'll see the architectural wall panel. So both our roofing and cool room panel are FM approved, which means when your clients are trying to get their insurance premiums at a reasonable level, that's where FM Global will come in to help that. So it's a very in-depth testing that they do, and they come out to our factory and then send it back to the USA and get it tested properly. So all the insurance companies, the major ones, are behind FM Global. Um, the profile. Oh, sorry. With our cool room panels too. Sorry, we'll just jump. So we do standard width of 1100 wide. We can do a 1 meter wide panel as well. We do have 6 different thicknesses, starting at 50, going up in 25 increments to 150. The 200 mil that we do or can manufacture, that there is not FM approved. So we just like to make that aware to people that but predominantly 150 is what most people go for if they're building a freezer. Same thing, we can go from 2.4 to 24 meters. That's not a Maxam steel, that's just a CP coating on the steel, and we can, like I said, we can do swaged or flat. So that's the cool room. And then architectural wall panel. It's a concealed fixed product, so it can be run vertically or horizontally for wall applications. It's developed for clean contemporary architectural finishes. The width of the architectural wall panel is 1 meter. We only manufacture in 100 mil thick, and yet again 2.4 meters up to 12. We can stretch that a little bit, but up to about 12 meters. That does have the Maxam New Colour Steel coating on the exterior skin, and internal profile, yet again, swaged is our preference, but we can do a flat if needed. The benefits of using a Conqueror insulated panel. So when you're looking at building a shed or something like that, it does give you why would you use an Conqueror insulated panel? So the all-weather comfort, so it's a high performance insulated cladding that keeps you warm in winter and it keeps you cooler in summer. So it does exactly what it's designed to do. Energy efficient, so will help reduce your heating and cooling costs over the building's life. Durability of the product, so it's made in New Zealand for our tough conditions or climate, from coastal air to frosty inland mornings. It's a great product for that. Environmentally friendly, so it lowers the carbon footprint, which a lot of people today do love. So it's clean, bright interior finish, so it's ideal for modern industrial and commercial spaces.
Great. If you just go back once, I was also going to add, probably, Casey, where we've seen some real advantages of this product is particularly in the retail and showroom space. So that kind of trade warehouse retail, where you might be controlling the climate of a large space for customers, all those sorts of things. And in particular, under the new H1 rules that have come into play over the last couple of years, there's obviously been an increased focus on that. So it's been quite a good solution for that, for bulk retail, gyms or large spaces where you're trying to keep it comfortable for customers who are coming and going.
Exactly. And the other thing on that, on those spaces, those industrial spaces, is it reduces the chances of having to line the interior as well, because you've got that nice clean finish. You don't see netting, you don't see building paper. So we're finding more and more developers and that wanting to use an insulated panel in that sense. So installation, so it's very simple and efficient. So like I sort of got to on the last slide, is you can direct fix it to the Attika structure. So no complex systems or multiple layers. So no netting, no building paper. Just you've got the structure. You put the panels directly onto it, and that's a finished product. So single component solution, so it meets the thermal regulations while reducing installation time and labour. If you look at the map of New Zealand, and it is quite hard to see, but you'll see the different zones that H1 refers to H1. So you'll see the residential, which, as you know, we've got to be to R6.6, sorry. So 150mm panel will do that for residential, and walls is too. But if you go to the commercial side of it, and you see the different zones, so like the red, you can get away with a 75mm roof in the top of the north, because we're down central Otago, Southland, you need to get to R7. So our 150mm panel will go to 7.13. So that's the ideal panel for that. So detailing, so external flashings, as per the standard metal roof cladding practice, internal flashings, air seals for continuity and performance. We do have an extensive drawing and specification package, so available for designers and consent purposes. So we've got a technical team that can help us with anything, but yeah, we do have a full set of drawings available and details where required.
Thanks, Casey. That's really helpful. I just want to talk through a couple of case studies where we've used this panel. So we've used insulated panels on quite a number of projects in different circumstances, but these two here were, I guess, good examples in general. So first one there being Dyno Conveyors. So this business is a manufacturing business in Invercargill. We worked with them on a lot of detail, but they actually went and visited a couple of buildings that had PIR panel and were really impressed with the level of comfort. So they opted to use it for their factory. And the feedback we've had from them has been really positive in how much less fluctuation there is in temperature inside the building, reduced condensation, that type of thing, and just a much more enjoyable work environment through the Southland winters. And similarly with Black's Fast as well, this is probably a good example of those types of retail, larger retail buildings where you've got a large open space that's getting heated and cooled and kept at a comfortable temperature. So PII is a really good option for those types of projects. As Casey said, the alternative is likely with strapping and lining with bats. So if there's not a requirement to line out the inside of the building, switching out the cladding to a PIR typically works out quite a cost-effective solution for meeting the H1 requirements for a temperature-controlled space. We run through these FAQs, Casey.
Yep. Just on the Almanzo, just on that Black's Fasteners, that was built just after I started with Conqueror, and I remember when Blacks were moving into the building, I was down in Invercargill, and just the people that were moving into it, there was no heating, nothing on. It was a -2 degree frost, and it was like 12 degrees inside the building. It was so they didn't want to go back to their old building. I know that.
Yeah, I think I remember that story. Now you've jogged my memory. I think the previous building might have been a concrete, at least I'm thinking of another customer, but like a concrete precast building. That was really cold and stayed cold for quite some time. So big difference. Yeah.
So the frequently asked questions. So minimum order quantity. So with cool room panels, we do hold some stock. Now this is titania, so titania on both sides of the panel, and it's flat both sides, so not swaged. So we hold it in 50mm, 75 and 100mm, and we hold it in 2.4 meter lengths, 4.2 meter lengths, and 6 meter lengths, and that's all by 1100 wide. Other products, we prefer to try and get minimum order quantities of around the 50 square meter mark, and and I'd love to get anyone that would like to have a look at the factory at some stage. You'll understand why if you were to go through the factory. Just it's a big setup to change over to something else for a small quantity. So, design flexibility. Um, it's a simple system that really suits a gable or a mono-pitch building. Uh, you, any other thing, you can treat it just as any other cladding system for easy integration. So a lot of people get a bit nervous around insulated panel, but you're building a shed, you want to make it habitable. Yes, you could put single skin and then put bats and line the inside, or you just put a panel up and you've insulated your building straight away. So are values by thickness. So we've got all our data sheets on our Conqueror website. So for an example, 100 mil roof panel is R4.67, 150 is 7.13. So it's an installed value as well. So not just the panel, that's what it's been tested for as an installed R value. Lead times, typically around the 3 to 4 week mark. And that's depending on colour availability. So like I mentioned earlier, so we can do any colour New Zealand Steel have, but we do have 6 main standard colours that we use. Those there definitely will be in that 3 to 4 week mark. If it's a unique colour, that could be a longer lead time. Sometimes that lead time can drop below 3 and 4 weeks if we're manufacturing the same product within a couple of weeks. It might make good sense for us to actually put that in with something else we're running. Coatings, as mentioned, so our roofing and architectural wall panels, all New Zealand Steel or New Zealand Colour Steel max sand coating, which is suitable for most New Zealand environments. Warranties and specifics. So for our exterior cladding, it's 15 years. So that's your roof and your walls. Cool rooms, generally, it's 10-year warranty on cool room panels.
Thanks, Casey. That's brilliant. So I guess everyone that's got any questions as they've listened through, welcome to put them in the chat box. There's a couple I noted down that sort of came to mind as we're going through, Casey. First one being, I think this is back to, I guess, some of those myths based off some of the older flat EPS panels, but how does it compare in terms of risk of roof leaks for that trapezoidal profile compared to, I guess, a traditional colour steel 5-rib type roof? You any comments around that?
It actually works the same way. We still overlap the panel. Generally we don't get a lot of callback on leaking roofs. So I'm not saying it never happens, but
yeah,
and sometimes it could be the screws not being put down properly, or generally, especially with the longer lengths as well, that does help. So if someone's got an 18 meter long run to clad, we can do that in one piece. So that's reducing those chances of any leakage as well. So
it's reducing those joins, isn't it? Because I think, again, it's back to those conceptions. I think years ago there were a lot of flat panel was used as roofing, which I think would have relied quite heavily on the sealant between the panels. But obviously we're dealing with quite a different product. So not everyone.
Quite often with a flat panel, well, something we recommend with a flat panel is obviously, yes, of course, sealant, either some kind of membrane over top of it, or on the joins you put like a flashing over the top. There is a name for it, and I can't think of it off the top of my head. So
I know what you mean. But it's having that trapezoidal profile is a big advantage. From the
Totally.
outside, it looks like a five-room roof, performs the same way, and more or less much the same way to flash and deal with those water tightness issues as any other roof. So
Correct.
yeah,
Yeah.
good. Probably a comment, if you is around the structure is obviously Attica. We have our own modular structural steel system. So we've worked in a lot with Conqueror and the likes on these insulated panels, and there's obviously a cost difference between your standard colour steel versus an insulated panel. There is a little bit of an offset with regards to being able to space purlins out and do a few things like that as well, because the panel can span a lot further than a single sheet of iron.
Yes. And one thing we do on that is we have got our technical guys in that we can help. We've got span charts. So we have to take into consideration wind zones and snow loadings, but
Yes.
we're there to help. So
Great. Okay, I've had one question coming from Michael, saying, "Hi Casey, what common detailing or specification issues do you see from designers and architects, and how can we best avoid them early on the design phase?" Guess he's asking us, what mistakes do you see architects make?
um, I don't like answering that, but um, yeah, you do. We've seen a couple recently where they've tried to bring the wall up, and then to meet the roof like that, where we prefer the roof going over top of the wall. So just
Okay.
little ones like that. What else have I seen recently? Just probably as an eave. So a lot of people will try, and when it's unsupported, the roof line comes down over your wall, and they want to create a soffit or something like that. The panels, you probably really want to go sort of only between 400 and 600 mil maximum. You don't want to be
Okay.
going out a meter, 1200
Yeah,
unsupported.
okay. That's interesting. So I hadn't heard of that, but I can see how someone would think that's basically trying to cantilever the panel out,
Yes,
to give some kind of an overhang where it's not really designed for that.
correct. Yep.
Yeah. Probably what one I've seen, is just some designers not, you know, just changing it out for another roof when they could have optimized some of the purlins and that type of thing, or even on the wall girts a bit more efficiently, rather than just switching out as a cladding. So obviously, you know, wastes the client's money. Um,
Yes.
Good. And we've had another one of asking for once we're longer than 18 meter, what's the standard procedure? So I guess once you've hit your length limit, Casey, what's the general?
So 24 meters is our absolute maximum. We can't go 24 meters and 50 mil.
Yeah.
So we've cut it at 24. Um, the procedure is obviously we need to know the site. That's probably before we get into transport. We need to know the site, and can you actually get a 24-meter panel to your site? Because um, yeah, we have had them in the past where a building's been in the middle of other buildings, and on paper it looks great. The 24-meter panel will go on top of that building, but if you can't get the panel to the site, um, it's not going to work. So that's probably not a hurdle, but it's something that we have to take into consideration. As for transport, it, generally you start getting into pilots, and it can be done. We've sent 24 meters panels to the North Island in the past. Driving around the Kaikoura coast, I was thinking there's no way, but they don't go that way. They go up through the middle through Waiau and then come back out just by the golf course in Kaikoura. So
And I guess where there is, you might have a roof that's say 20 meters long and it's not practical to pilot. Um, you've got a standard joining detail. Our team's used it before where we can join the two panels like, similar to what you would do on a colour steel roof, really. I mean, it's the same
yep.
limitations in many ways.
So we have got a step detail as well, where you can step the panel down. So, and that is in amongst our standard detailing that we have, or drawings that any designer can get their hands on if they come through us. So, yeah.
Very good. Okay. I don't think any other questions have come through. So, look, really appreciate you coming on, Casey. Thanks for your time and appreciate your insights you've shared. And yeah, this has been recorded, so we'll have that to be able to use and send out to those registered that make it on, and you know, keep the information informed the industry. So appreciate what you've shared on everything else, unless you had any parting shots.
No, I just really appreciate being invited to come along to your webinar. Really enjoying working with you guys at Attika. It's a great company, and Alpine Buildings as well. So yeah, thank you very much.
Very good. Thanks, Casey.
Thanks.
Cheers. Thank you.
Bye.
Bye.